Hello, and welcome to the Health Data Ethics Podcast. I'm your host, Jenny Owens, and today I wanted to spend some time talking about one of the scientific books that I just read. So I just finished The Codebreaker a couple weeks ago. Codebreaker is about Jennifer Doudna and her work on CRISPR. It's written by the excellent biographer Walter Isaacson, and I actually read it as kind of a counterpoint to Walter Isaacson's new book about Elon Musk, because as I was reading through his Elon Musk biography, I found myself kind of getting crankier and crankier about how science, how do I want to put this? How cavalierly Elon tends to treat science as if it can be done by one person and a proof of concept is the same as proof, which is not really the case. And I got really angry at Walter Isaacson. Not really angry. I got irritated with Walter Isaacson for taking Elon so much at his word, right? So I thought, well, let's be fair to Walter Isaacson, who after all has a Pulitzer Prize, has written a bunch of biographies that I have really enjoyed, right? Let's go back and let's read his book on Jennifer Doudna. And what I found in The Codebreaker is an absolutely beautiful portrait of science as it is really done in the first quarter of the 21st century. So it's and in full disclosure, so my background is in basic science. I have actually worked in recombinant DNA, although I came of age in graduate school in the era before CRISPR. So I was still using zinc finger nucleases and doing some other stuff. So I'm really excited about this technology. It's going to make science a lot faster and a lot easier. But what I was really struck by in his portrait of Jennifer Doudna is how beautifully and tenderly he sketched not only the entire scientific community around what it takes to bring an innovation like this really to life. So it's not just the Codebreaker is not just about Jennifer Doudna, although she is the central figure. It's about her collaborators, it's about her mentors, it's about her graduate students, and it is really an accurate portrait of academic science today. It's fantastic. I think it's a definite must read. If you are not big on biology and not it's going to be a nice primer on DNA and DNA technology. And one of the things that I really appreciated was that Walter Isaacson took not only a deep look at the academic scientific community around the CRISPR technology, but he also took the time to place CRISPR technology and the concerns about CRISPR in the context of the recombinant DNA panic and the overall ethical conversation about gene editing. I thought this was really interesting. So again, I came of age post recombinant DNA panic. So the recombinant DNA kind of moral panic is a hallmark of probably the mid to late 70s, when we were still, and when I say we, I mean science, was really figuring out how can we synthesize DNA, right? We understand the structure. Can we make it ourselves? Can we genetically modify organisms to study them better and to understand what this important biological molecule does better? So when I was learning about this, one of the things that has always stuck out to me is that the city of Boston actually banned research into recombinant DNA. And I am so used to thinking of Boston and Cambridge as such a biotech hub that the idea that the city would just stop any sort of groundbreaking research is absolutely mind-boggling to me. It's like, let's say, the city of San Francisco today said, actually, we're just going to put a 3-month ban on AI. You're not going to do any research on it. You're not going to use it. We just need to pause and think about what this all means. It reminds me a little bit of Atlas Shrugged, right? With the overarching, like, oh, we just have to stop. We just have to stop everything so we can catch up. I'm making a lot of political statements that perhaps I don't fully intend there, but it does remind me of that, right? So I think it's interesting both to place Jennifer Doudna's work in the context of the ongoing ethical concerns about what it means to be able to modify DNA, and also to place her in the context of science as self-governing, right? Because we spend a lot of time talking about Asilomar. So the Asilomar Conference on Recombinant DNA was a hugely influential conference that happened in California, when the scientific community kind of got together and said, okay, we're going to lay some ground rules. We're not going to wait for government or for industry or for bad actors to take this over. We're going to set some ground rules for ourselves. And in the context of CRISPR, Jennifer Doudna was actually instrumental in reconvening kind of I think they actually called it Asilomar 2. to talk about, okay, well, now we have better, more precise tools for gene editing. We have a technology that could, in theory, be used in human cells. I don't believe it had been tried at the time. The timing of Asilomar 2 and the babies that came out in China. I would need to go back and double check. But anyway, the technology is possible to use in human cells. So it's really interesting to me to see science grapple not only with the ethical implications of their technology, but with the practical implications of needing to self-govern and to say, okay, well, these are our rules. We're not going to do this for any gene for which there exists a therapy that is effective today. Right. That was one of the big overriding ethical concerns that came out of Asilomar 2 was, we're not going to, for example, look at gene therapies for like for diseases for which we already have a really good treatment. There's no need, right? We have a treatment. Therefore, we don't need to take this next step into germline gene editing. There was a large actually press kerfluffle about a scientist in China who actually modified human embryos to remove the receptor for the HIV virus. So these babies they cannot be infected with HIV in theory. How one tests that is tricky, but in theory, they lack the receptor for HIV to enter cells, which is great. It would be great if nobody got HIV. I think we can all agree about that. I think we can all also agree that HIV therapies, antiretrovirals, and prophylactic therapies have come a huge way in the past 10, 15, 20 years. And so at this point, modifying people so that they can't get HIV, probably not our highest ethical priority. So I thought this was really interesting. But the thing that stuck out to me was that Walter Isaacson, as he does his beautiful deep dive, not only into, Jennifer Doudna and her work, but also into science and self-governing, says, okay, cool. What happens when we have our scientific anarchists, right? The folks who don't want to play by the self-governing rules. He spends some time with one of the prominent biohackers, Joshua Zahner, actually documents him injecting himself live with materials on stage that are supposed to modify his genes to make him more muscular and smarter and faster and all that. And I think it's really interesting because the limits of self-governance are, of course, that you lack enforcing power, right? If I say I want to brew up some stuff in my garage and inject myself with it, academic science might be like, Jenny, don't do that. We're not going to publish your papers. You won't be invited to speak at our conferences. Like, cool, I'm okay with that. I'm going to go ahead and do it. The ability to enforce is kind of weak when you are self-governing as an academic field and not as like a government entity or any sort of regulatory agency. I think this is really interesting. There's obviously really interesting parallels to AI here, right? So if we look to history as a lesson, with the concern about recombinant DNA, and Congress in the 70s heard bill after bill after bill to try to tamp down and really kind of box in what we could do with this scary new technology. And in the end, it was difficult to reach consensus. I see a lot of echoes of this with AI today, right? There are compelling arguments to be made on all sides. I'm not much of a, robot revolution will end us all. I'm also not much of a let people do whatever the heck they want, and I guess we'll figure it out once something bad happens. I do think it's interesting, though, to see how we can learn from academic science's attempts to self-govern. If we look at Asilomar 1, if we look at Asilomar 2, I'd like to learn more about what we're doing to self-govern in AI. I'm curious to know if this is more fractured because of all of the different implications for AI. Recombinant DNA and gene editing really I can't say only has implications in the biological sciences, right? But it is fairly narrowly limited, right, to biological organisms. AI has implications for all sorts of fields. I'd be curious to see if we were to put together a broad self-governing principle, what would that look like?